I'm going to take you through the process of building your isotopes using the interactive. When you first arrive to the interactive website, just reset everything. If you click on the motion, that'll stop the electrons from moving, which is probably a better idea. And then click on reset. So now you've got empty shells and nucleus to start building. So we're going to build 3 carbon isotopes, carbon 12, carbon 13, and carbon 14. So carbon has an atomic number of 6. This means it has 6 protons in its nucleus. Notice over here the elements are changing based on how many protons. So we just need one more. Now we've got carbon. Okay, so we want neutral atoms. So protons are positive, and we need to balance that with the same amount of negative particles or negative electrons. So we add 6 electrons to our atom. Okay, and that's the starting point for all of the isotopes. They've got the same number of protons, the same number of electrons. The only difference is the number of neutrons in the nucleus. So carbon 12 means that there's 12 particles in the nucleus. So we've got 6 protons, so that means we'd have 6 neutrons. So we add 1, 2, 3, 4, 5, 6. Okay, so now we've got an isotope of carbon called carbon 12. It's a stable isotope. It's neutral, as I said, because we've got the balance between positive particles and negative particles. And this form, or this isotope, carbon 12, is the most common form of carbon. There's about 98.93% of all carbon atoms in the universe are in this form. Okay, so we've got 2 more isotopes to build. So before you build the next one, you need to take a screenshot of your model and then paste it into a Word document. So the second isotope to build is carbon 13. So the only difference, we've got the same number of protons, the same number of electrons. The only difference is the number of neutrons. So it's got 1 extra neutron in it. So that makes it carbon 13. It's still a stable isotope, but it's just not as common. There's only a very, very small percentage of all the carbon would be in this form. Okay, so once you've built this one, you take a screenshot and you paste it into your Word document. So the third isotope to build is carbon 14. So again, the only difference between the isotopes is the number of neutrons. Because they're carbon's atomic number 6. It has 6 protons. Neutral atom of it has 6 electrons, and the only difference is that we've got this 1 extra neutron. So that makes it carbon 14. Okay, notice here we've got, it's now radioactive. Okay, that means it's an unstable form of carbon, which tends to break down and decompose. Okay, which we'll talk about at another time. So you take a screenshot of this third model and paste it into your Word document. I've created a template in Word doc, in the Word document, to show how to set out your task. So your screenshots will go in here. Okay, so you've got your 3 different isotopes, but you're going to have at least 2 element. So I've given an example of carbon. You're going to choose 2 other elements such as calcium or titanium, and you're going to do a similar thing for each of those. So you could summarize the information in a table. So as you see, I've given you blank templates here, so you can do the same thing. So you're to summarize the 3 different isotopes of the elements that you've chosen. You're going to summarize the atomic number, and you'd find that all of these should be the same. So the atomic number for each of your isotopes should be the same. Your number of protons should be the same. Number of electrons should be the same for your chosen element. They should all end up being neutral because you've got the same number of protons as electrons. And it's the number of neutrons for each of your isotopes should be different. And the stability, that will depend on which ones. If you can find at least one radioactive isotope of the element you've chosen, that would be very good. And then you're also to include notation if you can. Now, or you can just circle the notation here, draw a circle around these to show that they're different as well. But this is using, if I can show you from, no, I'm not going to be able to show you. You can copy these things and then just change what you need to. They're just in the equation maker. Okay, and then from this information here that you've summarized, I want you to note, explain or describe the similarities and the differences. So for example, the similarities will be very consistent with all of the elements that you've chosen. So in this example, the isotopes are carbon, so they should all have the same atomic number. They should have the same number of protons. They should have the same number of electrons. They should all be neutral atoms because of that balance between positive and negative charges. The differences between your different isotopes will be the number of neutrons, okay, and the notation should be different because you've got a different, and that's incorrect. I've got to correct that one. That should be carbon 14. Okay, so this is your mass number up here. That should be different. This is your atomic number, this 6 for carbon. So that should be the same for the notations of whatever you've chosen. And identifying the differences also if any of your isotopes are radioactive. Okay, so you identify that some are, for example, these 2 are stable, but we've got one that's different and it's radioactive.